Welcome to Zaption Tour 7-5, Rational Exponents and Radicals. There are 6 boxes, so let's get going right away. Here is box number 1. The first idea I want to teach you is the parts of radicals. Now you may have seen this thing before here. Okay, this thing that I'm putting in this green cloud for you here. But I want us to be able to do 2 things. 1, identify all the parts, and 2, be able to read it, okay? So let's learn how to read this. The way that you would read this is by saying this, the nth root of A. The nth root of A. So when you see that, it's read the nth root of A. Let me give you an example down below. This would be the 5th root of 32. So we would say this as the 5th root of 32. That's the appropriate way that we would say it mathematically. Okay, now that we know how to say that, let's talk about what these things are, okay? The n up here, this right here, this is what's referred to as the index. Okay, it's referred to as the index. That's the word that we give to that part right there. The index is n, okay? The symbol, this black bar right here, this symbol that you've seen before, this square root symbol, or as many of you would think of it as, this is actually called the radical sign. R-A-D-I-C-A, sign. Okay? So that piece is called the radical sign. It doesn't have to be a square root. It could be a cube root. It could be a 5th root. It can be lots of different things. So we call it the radical sign. So the n is the index. The black is called the radical sign. And the part underneath, this a right here, this value, this is called the radicand. So let me spell that out for you. R-A-D-I-C-A-N-D, the radicand. So here are the 3 parts. We have the index, the radical sign, and the radicand. And the way that we say these things is the nth root of A. Box number 2 is all about finding a root. And I'm not sure if anyone's ever explained to you what a root actually is, but a root is the number by which we multiply by itself the index amount of times to equal the radicand. So I'll say that again, read it to you. It's the number by which we multiply by itself index amount of times to equal the radicand. So let me give you a bunch of examples here. And these are examples of finding roots, okay? So here we go. I'll leave this here so we can refer back to it. So part A says, the way that we read this is the cubed root of 125. So let's ask ourselves, what would the index be? Well, the index is 3. So therefore, I'm looking for a number by which I can multiply by itself 3 times to give me the radicand, which in this case happens to be 125. So what number does this have to be? Well, it has to be 5, right? Because 5 times 5 is 25, and then 25 times 5 is another 125. So therefore, this has a value that's just equal to 5. It's not the number 125, it's the number 5. So it is the number by which we multiply by itself the index amount of times to equal the radicand. So the cube root of 125 is the number 5. Okay, I hope this is making sense so far. Part B says the 4th root of 16. So I want a number by which I multiply by itself 4 times to give me back the number 16. What number would that be? Let's try the number 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, so therefore the answer is the number 2. The 4th root of 16 is the number 2. Okay? Example C says the cube root of 27, so I'm looking for a number by which I multiply by itself the index amount of times, which in this case is the number 3, that's my index, to give me a value of 27. That number, which all of you should probably realize, is the number 3, right? Because 3 times 3 is 9, times 3 is 27. Therefore, the cubed root of 27 is the number 3. Let's do a couple more together. The 5th root of 32. This means a number by which I multiply by itself 5 times, because the index is 5, to give me a value of the radicand, which is the number 32. What number would that have to be? Well, that number is also 2, right? Because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So therefore, the 5th root of 32 is the number 2 also. Okay, hopefully this is sinking in. We'll do 2 more for you. Okay, this says the cubed root of 64. It means a number by which I would multiply by itself the index amount of times. The index is the number 3 to give us a value of 64. What number would that have to be? Let's try the number 4. Okay, 4 times 4 is 16. 16 times 4 is the number 64. So therefore, the cube root of 64 is the number 4. Hopefully this is really sinking in for you. Okay, last one here is the square root of 36. Well, this one's pretty straightforward. Just a number I multiply by itself 2 times to give me 36. And that, of course, number would be the number 6, because 6 times 6 is 36. So therefore, the square root of 36 is the number 6. And we're talking about the principal square roots in all of these, and we'll get into that more later. I don't know why this one's orange, by the way. It just happened to be. Hopefully that makes sense to you. Box number 3 is a key concept, so let's make sure we take note of this. There are 2 key concepts that I want to introduce to you. Number 1 says the nth root of a is equivalent to, and I have this little blank box over here, and what it is equivalent to is equal to this. It's equal to a to the 1 over n exponent. Okay? Everything on the left-hand side over here, this is called radical form. And you could probably guess why it's called radical form, because there's a radical in it. And everything over here on the right side of my equation is called exponential form. And you could probably guess why it's called exponential form, because there's an exponent in it. So the rule says the nth root of a is equal to 1 over n. Now, what if you have the nth root of a to an m power, right? Because right here, the power on the radicand is the number 1, so you can see that it showed up right there. And we don't ever write that, but that's where it comes from, okay? So what if we have another number other than 1, like an m? Well, the first step is to realize that this is equivalent to the following. It's equivalent to the nth root of a all raised to the m power. So it's almost like this exponent is allowed to come outside. That's an equivalent statement, okay? And if that's the case, then we are allowed to write it as a to the m over n. It doesn't look like an m, I'm sorry. A to the m over n. It just takes the same place of where the 1 was before in the first part. So again, on the left-hand side, this is called radical form. On the right-hand side, this is called exponential form. And we're going to be able to change from one form to the next in the following 2 boxes. Okay, box number 4, we're going to do 2 examples of converting to radical form. Right now, hopefully you see that all of this is in exponential form because there's an exponent in it. So you have to ask yourself, what's the exponent on the 12? The exponent on the 12 is just the number 1, so I don't really do anything to that because it's just the number 1. So this is going to be 12, and then I have a to the 2/3. This is going to be equivalent to the cubed root of a squared. Because remember, a to the 2/3 can be written as the cube root of a squared. That's that rule that we just learned back in box number 3. So 12 times a to the 2/3 is equivalent to 12 times the cube root of a squared. We're going to do some more problems in class, but I just want to introduce this to you. Okay, let's take a look at this one here. 64a to the 5/4 power. Okay, I think I just said 5/4 power, but obviously it's 64a to the 4/5. So again, the exponent on the 64 is just the number 1, so we don't do anything with that. So we have 64 times the 5th root of a to the 4th power, and that's as far as we can take this one because the index is larger than the exponent on the inside. So I have 64 times the 5th root of a to the 4th power. Okay, box number 5, let's convert to exponential form. There's 2 examples. It says the 5th root of b to the 3rd. Well, that is equivalent to b to the 3/5 power. So we have gone from radical form into exponential form. That was a pretty straightforward example. Let's take a look at example B though. Okay, this is going to be, notice that all of this stuff inside of here can be raised to the 1/3 power. So then I could take this and say this is 27 d to the 5th all raised to the 1/3 power. Okay? Because remember, the cube root of whatever you have underneath here is equal to star to the 1/3 power. And my star just happens to be 27d to the 5th. Now remember our rules of exponents. Let me move over a little bit. If I am raising a product to a power, then everything gets raised to that power. So this is going to be 27 to the 1/3 power times d to the 5/3 power. Because I am multiplying a power to a power. That's where that 5/3 comes from. Okay, 27 to the 1/3, well, that means what number do I multiply by itself 3 times to get me 27? And that is the number 3. So this has a value of 3. And then the leftover part that I have is just d to the 5/3 power. So I have taken my radical form and I have changed it into exponential form. Okay, box number 6. We will practice more examples together in next class meeting. I know this was kind of a challenging Zaption tour, so we will definitely practice some more, so don't worry.